This is a video walkthrough for practice 1.1. In 1 and 2, we're asked to find the sine, cosine, and tangent for each acute angle in the right triangle. And we're going to simplify each ratio and rationalize all denominators. So that means no radicals and denominators and final answers. Okay, so in number 1, we have 2 sides only given for this triangle, but this is an 8, 15, 17 triple, so we can know what that third side is. For angle D, sine is equal to the opposite over the hypotenuse. Cosine is equal to the adjacent over the hypotenuse. Tangent is equal to the opposite over the adjacent. Now let's switch gears, and we're going to look at angle F. So for angle F, sine is equal to the opposite over the hypotenuse, cosine is equal to the adjacent side over the hypotenuse, and tangent is equal to the opposite side over the adjacent side. So those are the values for all of the 2 acute angles, D and F, in that triangle. Now let's take a look at 2. Again, we're missing a side, so we can use Pythagorean theorem to find the missing sides. The square root of 7 squared plus x squared is equal to 5 squared. So 7 plus x squared is equal to 25, and that means that x squared is equal to 18. And if we simplify, the square root of 18 is equal to 3 times the square root of 2. So 3 times the square root of 2 is our missing side. Sine of angle M is equal to the opposite over the hypotenuse. Radical in the numerator is okay, and a final answer. Cosine of angle M is equal to the adjacent side over the hypotenuse. And tangent M is equal to the opposite over the adjacent. Now this one has to be rationalized, so I'm going to multiply by square root of 2 over square root of 2. That gives us the square root of 14 over 3 times 2, or 6, as our final answer for that one. Sine of angle N, so now we're switching gears. So sine of angle N is equal to the opposite over the hypotenuse. Cosine of angle N is equal to the adjacent over the hypotenuse. And tangent is equal to opposite over adjacent. So that's going to be 3 times the square root of 2 over the square root of 7. Now we have to rationalize that one by multiplying by the square root of 7 over the square root of 7. That will give us 3 times the square root of 14 over 7 as a final answer for that one. In number 3, we have tangent of angle E is equal to 3 as given, and we're supposed to use that information to find the 2 missing sides. So I'm going to start with that piece of information. Tangent of angle E is equal to 3, and we know that tangent is the same thing as opposite over adjacent. Let's look at angle E. The opposite side is side E, and the adjacent side is 2, so E over 2 is equal to 3. We multiply both sides by 2. That will give us a value of E equal to 6. Now that we know 2 of the 3 sides in the triangle, we can use Pythagorean theorem to find the third side. So E squared plus 2 squared is equal to F squared, and E is 6. And so 6 squared is 36, 2 squared is 4, that totals to 40. So that means F is the square root of 40, which simplifies to the 2 times the square root of 10. Now let's take a look at the next exercise, very similar setup. So cosine of angle R is equal to the square root of 2 over 3. And we know that cosine is the same thing as the adjacent over the hypotenuse. Let's look at angle R. The adjacent side is 2, and the hypotenuse is Q. So 2 over Q is equal to the square root of 2 over 3. We can cross multiply here to solve this proportion. Q times the square root of 2 is equal to 2 times 3, which is 6. So that means that when we divide, we'll get 6 divided by the square root of 2. We need to rationalize that result. And that's going to give us 6 times the square root of 2 over 2. So Q is equal to 3 times the square root of 2 when we simplify that. And now that we know that value, we can use Pythagorean theorem to find the third side. So r squared plus 2 squared is equal to q squared, which is the hypotenuse. And r is what we don't know, and 2 squared is 4, and q squared would be 3 times the square root of 2 squared. So r squared plus 4 is equal to 9 times 2, or 18, which means that r squared is 14, and r is the square root of 14. In 5 through 8, we're going to write an equation that relates the indicated side and angle measures, and then solve, and leave the answer in the exact or calculator ready form. So in 5, we are going to refer to that 28-degree angle, and we have side C, which is opposite, and 5, which is the adjacent leg's length. So that means that we'll use a tangent ratio because tangent is the opposite over adjacent. So initial equation is tangent of 28 degrees equals C divided by 5, the opposite over adjacent. We can multiply both sides here by 5. So 5 times the tangent of 28 degrees is equal to the length that's represented by C. That's our calculator ready form. In 6, we're working with the 57-degree angle. We have the side that is of length 8, which is opposite 57 degrees, and W, which is the hypotenuse. Opposite and hypotenuse are in the ratio for sine. So we'll use a sine ratio. Sine of 57 degrees is equal to the opposite divided by the hypotenuse. I'm going to clear the fraction by multiplying both sides by W. So W times the sine of 57 degrees is equal to 8. And now divide by 57 degrees, sine of 57 degrees. And we have W is equal to 8 divided by the sine of 57 degrees. And that's our calculator ready form. In 7, our angle isn't given, but rather the thing that we're looking for. And with respect to angle V, the square root of 7 is opposite, and 4 is the hypotenuse. So we are going to use a sine ratio. Sine of angle V is equal to the ratio of the opposite side length divided by the hypotenuse length. And now we have to remember that to undo a sine, you need to use an inverse sine. It's not a multiplying relationship where we can divide. So the measure of angle V is equal to the inverse sine of the square root of 7 over 4. Make sure that you write the inverse sine on the left side of the square root of 7 over 4. Otherwise, it's not really a meaningful notation. In 8, we have angle B, and side represented by the length 5 is opposite, 3 is adjacent leg. So that means we're going to use a tangent ratio because tangent of angle B is equal to the ratio of the opposite side divided by the adjacent side. In order to undo tangent, we're going to use an inverse tangent operation. So the measure of angle B is equal to the inverse tangent of 5/3. In number 9, we're finding the measure of the smallest angle in a 5, 12, 13 right triangle. So I'm going to draw a picture, and I'm going to try to draw it accurately here. 5 is the smallest of the 3 sides, 12 is the adjacent leg, and 13 must be the hypotenuse. The smallest angle, I hope it's obvious from the picture, if drawn accurately, is going to be over here opposite the smallest side, 5. So I'll call that angle theta and write an equation, and you can pick your favorite of the 3 ratios. It doesn't matter which one you pick. So I'm going to pick tangent. So tangent of angle theta is equal to the opposite divided by the adjacent leg length. And in order to undo the tangent, we'll solve for the angle theta, and theta is equal to the inverse tangent of 5/12. By the way, you can have the inverse sine of 5/13 or the inverse cosine of 12/13. All 3 of those are valid answers. In 10 through 11, we're finding the height of each triangle. Remember that SOHCAHTOA is only good for right triangles. So here's a right triangle within the picture.